Okay. Good evening, everyone. Hi, I am Avijit Dattagupta, your today's host, and welcome to the 4 days summer camp on astronomy and citizen science. Our today's speakers are Shourjya and Amritanshu Vajpayee. Am I audible? Hello.
Yes, sir, you are audible.
Okay, okay. Uh, so, this summer camp has been organized by Hexstar Universe, Citizen Science Lab, Astrogen, Astrobits India, and IIT Hyderabad Astronomy Club, and Agnirath Aerospace and Defense Research Private Limited. We are really thankful to them. They have organized it, and thank you everyone for joining. So let me introduce to Shourjya. He is an galaxy analyzer, supernova hunter, and he have submitted his artworks in NASA also. So uh, that's great, and we can start now. Okay.
Okay, sir. So, good evening, everyone. I'm Shourjya. I'm a student of class 8 reading in the North Point English Academy, Malda. And I am honored and I'm grateful as because the organization that is STEM, STEM as a Citizen Science Group, Agnirath Aerospace and Defense Research Private Limited, Hexstar Universe, Astrobits India, Astrogen, and many other organizations has called me in this summer camp along with other respected speakers. So today I will be reflecting the lights on the topics that is the supernova hunting, the kilonova hunting, and galaxy classification, and I will say something about the space art. And so let's start. Please give me a minute to share the screen. Yes, sir. So at first, as we are heading to the topic of space exploration, that is, that we have also seen that the tourist topic is space exploration. We must know that why we will discuss about space, although we are having other subjects. So we will be fascinated to know that space is the most varied and the largest laboratory we ever have. Fahrenheit, which we can find in the Buberang Nebula. You know that we can't find these temperatures in our Earth, but it is possible in our space. And as I told you that space is the largest laboratory, and you know that the reactions are taking place every moment there. The peaceful and the night sky, which we observe, is like a trailer of the movie. But sometimes we might observe the effects of those reactions in the night sky. Recently, news of the polar lights, become viral to all the space enthusiasts. And to your surprise, the polar lights is also an effect of such a reaction. And the polar lights are distinguished mainly into two main sections. The polar lights in the North Pole is known as the Aurora Borealis, and the lights of the South Pole is known as the Aurora Australis. But those who live means those like us who lives near the equator cannot see the beauty of this natural colorful light. But behind this effect, there is another story. This happens because of the excessive storms of gases that takes place in the sun. because the sun is burning every moment. It's a gas giant. To enter the atmosphere directly. So we can assume our Earth as a massive magnet. And this is why we can find the direction with the help of a compass. This is why, because of the magnet only. The magnetic field turns that in the north south direction, and you know that the magnetic field has a deep relation with electricity. And as a combined result of the magnetic field and electricity, many electrical instruments works. But other than the storms, the powerful molecules come towards means our direction, means the direction of our Earth on a regular basis. And as these atoms are charged, they always undergoes a reaction with the Earth's magnetic field. I told you before that the magnetic field of the Earth sends the solar molecules to both the poles, both that is the North Pole and the South Pole of the Earth. And when the molecules go to the poles, they enhances the energy of the air molecules present there. Then the electron of the atoms of those molecules become powerful for some moment of time. And but after some time again, the electrons return to their initial stage by losing their energy. And that energy which is released, then it reaches to our eyes in the form of different lights, and this is what we call as aurora borealis or aurora australis. And the lights which we can see because of several gases. The oxygen deflects green, brownish, and reddish light, whereas nitrogen deflects bluish and reddish light. And the polar light is one of the result of a certain reaction, because there are innumerable reactions means happening every time. But other than those, if we look at the night sky, we will see several magical things. And to observe those, we can take the help of the telescopes. As because of pollution, we can't see anything in the night sky through our naked eye. And there are certain observatories also, like they are located in the placed in the offbeat areas, where they capture the photos of the celestial pictures, and they sends the pictures to us. And to capture the other things like the interstellar rays, waves, and light such as the microwave and the gamma rays, radio wave, ultraviolet ray, X-ray, we must set a telescope in the Earth's orbit, means outside the atmosphere, Earth's atmosphere. And the Hubble Space Telescope is the first space telescope which was set in 1990. And the James Webb Telescope, which you can see in the right side of the screen, is also an example of this type of telescopes. And now we see that all the projects, that means all the things, that observatories, the space stations, or the telescope that is set in outside the Earth's atmosphere, is all done by the means professional scientists, those who have the degrees. But that we can also assist the professional scientists. We can also become and work as an assistant of them. And here only the concept of citizen science comes. And that you have might seen that in the newspapers it is published that a group of students or a group of college students has discovered an asteroid or a comet with the help of other citizens, means other professional scientists. So, did you wonder that what is the role of the students and how they are helping the professionals in this field? The answer to our question is that they are citizen scientists or amateur astronomers, which you can say. As you know that our universe is an infinite field, and with the help of those telescopes, a large number of slides and pictures are provided to us every time. And so it becomes impossible for the scientists, those who are limited in number, to check those. But the citizen science projects has a vast contribution to the field of astronomy. Then how? Because they, what I will say, they help those professional astronomers by doing the preliminary detections. And now see, the citizen science projects approach the non-scientist, but those who are interested in space and interstellar objects to work in various interesting but simple projects. And I told that they seek our help to provide the professionals by doing the preliminary detections. And it's very interesting that irrespective of age and profession, you can avail these projects. And not only space, there are several subjects in which the citizen science projects are there. And some of them I have displayed in my slide. There is geography, universe, physics, meaning of life, statistics, cities, culture, map making, that is cartography, farming, connecting to nature, etc., and biodiversity. And personally, I work for the ESA Citizen Science Group, which is the International Citizen Scientist Group, the group of Shobhanacharya sir. And recently, I also got one team, means that I got the leadership of a team, and the name of the team is ESA Citizen Science Lab Malda, which was started to work for several interesting but simple citizen science projects for 2 months. And that in the future also our team members who are in this it's a citizen science lab Malda will be participating on projects such as asteroid hunting, gamma radio burst, and galaxy classification, supernova hunting, and kilonova seekers project. And I will tell you one by one about those projects. Science. In the slide, you can see that a picture of elephant is there, means biology is also there, space is also there, moon, and means the research papers are there. And you know that in 2000, in the previous year, the White House Office of Science and Technology Policy, year of open, they means led a competition that is Open Science Recognition Challenge, and there Universe came to receive the White House Open Science Award, and it's a matter of pride for us as this is citizen science platform which we can avail for doing several interesting citizen science projects. And here we have the supernovas and kilonovas. So I will be going to some two projects are there about supernova, that is supernova hunting and kilonova seekers. But at first we need to clear the concept that what is the difference between supernova and kilonova. So you know that a supernova is a powerful and luminous explosion of a star. A supernova occurs, you can say, during the last evolutionary stages of a massive star or when a white dwarf is triggered into a runaway nuclear fission. But kilonova occur when two impact objects like binary neutron stars or a neutron star and a black hole collide. These mergers, as their name suggests, are about 1,000 times brighter than a classical nova, but not as bright as a supernova, which is 10 to 100 times brighter than a kilonova. You can see the pictures of supernova on the top and the kilonova. Kilonova is a more massive explosion than a supernova, as you can see in the pictures. The first image you can see is from a telescope, but the second image is not a telescopic image. It's an means image which is developed by the graphics, so it's not the perfect one. So now I will show you and the Supernova Hunters project, and I will tell you how to do this. So as this is a workshop, I will be describing you that how these projects work and how to classify the supernovas, detect the supernovas. So let me, yeah. This is the Supernova Hunters project's homepage, and this is a project of this universe. Yeah. So this is a project of this universe, And most of the projects, means 19% of the projects uh, of this platform don't require any desktop or help of a telescope or laptop. So those who are sitting in their home by thinking that, oh yeah, I have no telescope or I don't have desktop, but they can surely come with these projects if they have a smartphone and the internet connection. So as we get started, that this project is actually, the slides are finished, but to explain to you, I'm doing that. And here it is, the tutorial is there. Welcome to Supernova Hunters. This short tutorial will show you how to discover supernova in data from the Pan-STARRS 1 telescope. Means the images that we are getting for this classification, means detection, is coming from the Pan-STARRS 1 telescope, which is located at the Hawaii island. And here you will be shown three images. In the center, a reference image is there, which was taken a few years ago. Means it might be between the range of 7 years to 12 years ago. And since then, a supernova has appeared in the more recent target image on the left. So the left image is the image of the same place few nights before. Means the middle image is the
Hello. Maybe he's facing some internet issue. Okay. Uh, we can wait a few minutes.
sir. Is my voice audible?
Yeah, yeah.
Yes, sir. Actually, I'm seeing that one of the members has muted me. Actually, so as
Okay.
I was,
Okay.
yes, sir. So can you
Let me
please
check
tell?
the issue. You can start now again. Okay.
Yes, sir. So as you that for, I think for certain inconveniences, my voice was not audible. I am sorry for that. And so I am repeating this project from the first. That is, in the Supernova Hunters project, there is a short tutorial, and which will help you to detect these images. And the images which you will see while detecting comes from the Pan-STARRS 1 telescope, which is located in the Hawaii Island. And you will be shown three images. In the center is a reference image taken a few years ago, and since then a supernova has appeared in a more recent target image on the left. Means the left hand side image is the image of the same place which is taken few nights before. And we can see on the right hand side there is a difference image made by subtracting the reference image from the target. That is, the target is the left hand side image, and this leaves any differences between the two and highlights the presence of a supernova. So as we move on, the problem we face means that is their internal current software, the current software in which the supernova hunters project is running, produces many bogus detections of supernova. To the computer, the above example looks like a supernova because the difference image shows a difference between the other two. But to humans, this looks strange compared to the previous examples of a supernova. And there are some same things about these bogus detections. So now I will be telling you how to detect these images. And you know that there is the finished slide, but I will, for demonstration, I will show you. In the middle slide, that the picture was taken 7 to 12 years ago, a range is there. In the green, crosshairs, in the center of the green crosshairs, we can't see any dot-like structure, white dot-like structure. But in the left-hand side image, we can see a dot-like structure in the center of the crosshairs. Means in between the 12 years to present, something has developed, something supernova has been created in that place. And so the difference image is there in the right hand side. So when we will see that there is no white spot or dot in the central image crosshair, but a white dot is there in the left hand image crosshair, we will not see anything. We will just put the yes and we will do done. And that is in the means in the bottom side of the slides, it's showing that you should sign in. So that's another important thing is that to avail this project, before doing this project, we must means develop an account in this universe with developing a password. And see, you can see that in the middle image also there is no means small dots or white dots in the crosshairs center, but in the left hand side a dot is there, small dot you can see. It's an example. So we will do the yes and we will do done. And as we do like this, and interestingly, one of the cases came where I can show you that, where you will have to do no. When you will see that there is an object in the crosshairs in the central image, and both in the crosshairs of the central and the left hand side image, then you will just put the no because it's not a real supernova, and you will do with it done. But if you need some help with this task, or if you have a doubt, you can go to the done and talk option, and you can need some help with this task. And that see that uh, it is yes, but if someone person has a doubt, and if I am doing no, we can if we do the done and talk option. Okay, there are no comments yet. Okay, there in several projects there are the comments where you can, means the experts are suggesting that this is. Now here will be shown that how the real detections are made. That if and they are trying to discover supernova which appear as a new sources of light. And if there is, and as I told you the same, if there is a detection on the left image that looks like a star, and it also appears in the rightmost image but does not appear in the center image, then it is likely a real detection of a supernova. You can see the real detections are there. And so after detecting, please, I'm coming back of this. Please give me some time to load this. And here, after the detection, means the committee of the Supernova Hunters projects, they provide us with a report in which the first three people, the first three citizen scientists who detects this supernova candidate or candidate, which you can say, their name is being published. But there, if an object is being classified by, if you can see, that is AT in the first, that is AT2020 ACNH, and suppose this transient supernova is being detected by 20 citizen scientists, The first three citizen scientists' name will be provided. So see, there are five. There is Enzo Fidel. There are many scientists' names, but the bold letters are there where the first three names are there. And there are the reports which you can see that whether your name is there or not. And after this project, if your name is there from the first three citizen scientists, you will be provided with, I told you that scientific report in which your name will be also there. I am having this three discovery certificates, and in this project, my name is not in this tangent. My name is not in the bold letters, and the bold letters are Cledison Marcos de Silva and Henrik Prozik and Gabriel Martins de Moraes. But in this discovery certificate, you can see that of the name of this 80 2022 WRK. And in the remarks section, you will find that this transient was discovered with the help of citizen science project Supernova Hunters run by Super Universe. The candidate was identified by volunteers including Ashok Ghosh sir, Shourjya, Manim, and Giovanni Colombo, who is also an eminent citizen scientist. I hope that this concept is clear. That is the galaxy, what I will say, the supernova hunting. And now this project is paused. Means as I show you that these slides are finished, and so the project similar to this which we can participate in is the Kilonova Seekers project. As I told you about the Kilonova Seekers project, and I will also like to show you about how to do this project. This is also a project of the Universe platform, and to avail this project too, we don't need any desktop or laptop or help of a telescope. We can just use this avail this project from a mobile phone. And the slides which you will get later means for after while detecting. These slides have been sent by the Gravitational Wave Optical Transient Observer, that is the GOTO observatory, and they are showing telling that the new data uploaded hourly means recently. So as we get started, you will be seeing that there is a tutorial, and they are saying welcome to the Kilonova Seekers. Please continue. And the image which you can see, that image shows the close up of the GOTO observatory in the tutorial. And you will be presented with trio of images, as you know, the same as uh, the supernova hunting project. There were also three trio of images. Here is also three images. And the first is a science image, that is the where a transient candidates had appeared in the region outlined by the white crosshairs. Next, in the reference image, means in the center of the image, template image of the sky region taken prior to go to taking science images. And finally, on the right is a difference image created by subtracting the template image from the science image. What remains in this image is new light, not observed in the template images, a potential transient. So this concept is also the same as the supernova hunting project. Here, the science, that is, you can see in the left hand side, the science image has been taken is a recent image. The reference image has been taken 7 to 12 years before, and that is the difference image. And their current software is good at finding the things, and it is very sure at real transients, and that it is very sure are bogus detections. However, they are particularly interested in observations where the computer is not sure, and they are told about the detection. And which you can see on the top, the three slides are there, means the tutorial slides. And here they have written this example is not a real detection and has been caused by diffraction spike from the bright star in the top half of the images. Means the reference image you can see in, means star is bright star you can see in the top of the image. So a spike has come down from that star, and so we will not detect it as kilonova. And if there is a real detection center in the science and difference image crosshairs, they will ask you, and if it is yes, you will do yes and no for no. And for some more examples of real versus bogus detections, please see the field guide on the right hand side of the screen. There is a field guide, and please click need some help with this task if you want more help. Have a look at the field guide for examples, and don't hesitate to ask a question in talk. So let's go. And so in this picture, we see a science, the reference and the difference image. And so there is not a particular star there. But if you need to help, you can please take the help of the field guide where you will see the means where they will show you that how they're there means it's real detection or not the right areas. So according to me, I think that it's not an real detection, and so we will do the done. I think this is also not a real detection, and if you have a doubt, you can do the need some help with this task where you will be shown the same as I told. To determine if a candidate is real or bogus, a good starting point is to look first at the difference image on the right hand side. That is, a real detection will contain a clear bright one, means they are here. And so after detecting, like the Supernova Hunters project also, they will be giving you the results in which some names are there from our team. Cledison Marcos de Silva sir's name is there, but I didn't this project a lot, so I don't have such a discovery. So I will be moving on to the next project, which is the Galaxy Cruise project. And you know that this project is being run by the National Astronomical Observatory of Japan. And this project is an interesting project which you can do with the help of your with the mobile phones and desktop also. And this National Astronomical Observatory of Japan also means they organized two special campaigns in a year in which you have to means what you have to classify the number of the galaxies, and if you do so they will put your name into the lottery, and if your name comes up from the lottery it will be given with the calendar and the greetings card, which you can see I've got for the 2 years, consecutive 2 years. So now going to the classification portion. At first we have to make means sign up in this. As we go up to the training, we will see the concept of the first elliptical and the spiral galaxies. You know, the round elliptical galaxies like rugby balls, and disc shaped spiral galaxies like pancakes are there. From above, you can see the spiral galaxies, they have spiral arms, and elliptical galaxies, they have ellipse like structure. And as have this concept clear, there are certain trainings which we can have. This is the, as you know, that these have spiral arms, you can see. This is a spiral galaxy. This is an elliptical galaxy because it's looking like an ellipse. And there are more means practice sets which we can do. I'm just skipping that. And we are moving to the lesson 2. And here we will be learning about the interacting galaxies. So some galaxies are interacting through their mutual gravity. affecting their shapes. These galaxies are called interacting galaxies. So when the gravitational pull of both the galaxy attract each other, they get diffused and they get interacted with each other. And there are, you can see there. Here, the question asks that is this galaxy is interacting? So yes, this galaxy is interacting. So like this galaxy is not interacting. We can do like this. There are several more practice sets. I'm just going to lesson 3. Here, the features that were taught about in the lesson 2, that is the interacting galaxies. In the interacting galaxies, there are several features also. Means under the interacting galaxies, there are several features, and among them is the rings, which looks like a ring, and shells, which looks like the shell, and tidal streams, that is tails, and distorted halo. You can show the features are there. Just going to the practice. It's in neither galaxy because this is not an obvious case because it doesn't look like elliptical and spiral galaxy. And you know that it looks like a ring. It has a ring shaped structure. And as we move on, this is an elliptical galaxy. And a tail like structure comes out from the bottom hand side. So here we will do the tails. And there are several other slides. And then training completed. They have completed the training sessions. And so you have given a boarding pass, which will help you to do the main classification. Yeah. Yeah, for the login also, like the Zunibus platform, we have also to give the names and the passwords for login. And the images of the galaxies, which you can see, has been captured from the Great Baruah telescope. And we have to classify these galaxies by completing the zone by zone. And this is an elliptical galaxy, not interacting. Submit. And this now the regular course is going on, and we can continue this. But as Amritanshu sir will also say about this, means I will say, so time is short. So that there is 2 special campaigns that I told you, and after doing those special campaigns, after classifying, if you classify more than 1,000 galaxies in those special campaigns, then your name will be published in their report, the publication report, in which the yellow highlighted names which are there are the name of the citizen scientists of Ex Citizen Science Group. Vikrant Kurmude, Jayan Kosar, Aditya Power, Amit Raka, and my name is also there, Sanchayan Sarkar. And this is the Galaxy Classification Project. And I told that after this, if you classify that, here the target was more than 1,200 galaxies. So some astronomers are there who have done the 1,200 galaxies, and after that, their names have been put in the report. And after that, that is, that in the ancient times, there were no telescopes to travel. Means before Hans Lavoisier invented the telescope. But a question arises that how would then astronomers can realize and find the stellar objects? And this is why space art or model comes to importance. And not only science, you need to apply your imagination also to this type of arts. And currently, there is a lot of acceptance of creativity in space in our means in our world right now. So as we move on, you can see the concept of space art and imagination has been coming off from the time of Van Gogh. The Starry Night is also an example of you can say a type of space art in which he has mixed the reality and the imagination to make this beautiful art piece. And that to start my cosmic art journey, I have to go back to 2020 when I started my space art journey. As I also had a knack to search for the latest news in the websites like NASA Kids and the ESA Kids, I saw that at first it was NASA Kids who was arranging an art competition named NASA Space Place Art Challenge. It's a monthly competition, which I'll be saying that I'll be showing you. This is the homepage of NASA Space Place or NASA Kids. Here you can see the NASA Space Art Challenge, and this month's art challenge for Earth Day, and the students have made that all over the world. And at that time, also in 2020, also I got a chance there to mix my imagination and reality. And as here's topic is the Earth Day, that time's topic was the Rocket Sentinel-6, which was programmed to be launched at November 2020. And the mission of the satellite was to check water level and the climate change of Earth. And the challenge was given to us at October month to draw the rocket Sentinel-6 with our imagination, which was not enclosed yet. And how would it be welcome to the space? And then I thought for some days and I did this artwork, which you can see. It's a mixture of watercolor, pencil color, and oil pastel. And I had needed to fill a form from JPL and attach that with my painting and had to send it to the NASA by email. And the age limit for this competition is up to 12. So the students, those who are means below the age of 12, they can surely participate in this. And those who are knack to draw. So and after 2 or 3 weeks, after 2 or 3 weeks after I sent, they sent an email and they also told that my email drawing has been displayed in their homepage, and this is that. And total 12 artworks are there from all over the world, and from there, mine one was there. And that I am sure that from the viewers those who are seeing this webinar, from there also some students are there, those who have the knack to draw, but they didn't have means the knowledge that it can be doing, so it can be done. So so let you can just like so means spaceplace.nasa.gov, and then you can see the homepage of this NASA Science Space Place homepage. And then coming back to 2023, it was the asteroid day, and on that occasion, the European Space Agency kids, yes, kids, you can see the homepage of this, and to search that, you can just uh, copy you can write it, that is esa.int/kids/en/home, and you will be sent in this ESA Kids website. As like this month's competition is robots in space, and so previously in 2023, that topic in the month in which I participated was the asteroid and comets. So I then made a model based on asteroid. This is the space gallery competition. Yes, it is. And this was my model of comets and asteroids. And after sending that, there's also they have also made the recognition by providing this certificate to us. And you know that this is also a very interesting topic because this is the commercial pure artwork. Means the category are there. That is, you can from age 6, age 4 to age 12. And here they publish our art, means our artwork in months of the calendar. And age group is there 2024 years. And if you go in this, that is nasa.gov commercial PO artwork contest. You can see all the means information and the instructions written there. And you know that when this project started, means when I observed this project that this project was happening, so then the lockdown came, and then in the lockdown period, this project was stopped, and for that I couldn't do. And after the lockdown, when the project again started, I was 13, so I lost the chance to send the artwork to here. But the chance is there to you. You can surely send your artwork, and I know that someone's artwork will get selected from NASA. And you know that those who thought that can't we participate, those who are more than 12 years, those who are the high school students, and their project is the Connecting the Dots 2024 NASA Student Art Contest. This is an yearly competition which is done with the partnership of National Institute of Aerospace. And you know the students which are there in the high school, means before, means more than 12 years of age, they can surely go with this project. And so at the last, I will say that as this webinar's name is Space Exploration, until date we have explored a little bit, means 5% of the whole universe. And you know the dark matter, dark energy. We are still to know this. We are still to discover many more things. So I hope that you will join your hands with this citizen science teams, and you will also come up for detecting this. And thank you, everyone. This was for today. I hope you enjoyed this. And again, I pay my warmest thanks to all the organizers who had called me in this webinar. And so, thank you.
Hello. I hope I am audible to you. Can you hear me all?
You're
Okay,
audible,
sure.
sir.
Sure. Greetings all. Good morning, good afternoon, and good evening to one and all. And special thanks to all the organizers who have organized this very wonderful, you can say, a set of talks in the form of a workshop, specifically aiming at the ignited minds of the future generation. I also congratulate all the organizers of citizen science projects. So now, you know, after you can say a look into or moving into a sea of the different citizen science projects, let's now blend our way forward to a little bit more depth in the form of something you can say a little bit you can say that will involve is machinery that involves your observational skills, machinery that involves your processing skills, machinery that involves your patience. That is, your I am here, I am talking about your body, mind, and soul. So let's fall in love with the subject that has been beautifully introduced by the first speaker of the day, Mr. Shourjya. So I just would request Shourjya ji to kindly stop sharing the screen. And in the meantime, you know, what happens is today, as it has been introduced by Shourjya, I just would like to take up from there. There is a concept that is known as citizen science. That is, each citizen or each global citizen, within each citizen resides a scientist. That has been beautifully explained and how the young ignited minds can participate. Now carrying it from there. Now once you take your first steps into the field of the citizen science, my dear young friends, you know what we basically develop. There is, if I am talking in terms of the context of the new educational policy that has been launched by the government of India, and even beyond, if you look at the different streams or different forms of you can say education, different systems of education spread across the globe, you see there is a focus on practical based learning, becoming more pragmatic, becoming more you can say skill oriented. So let me just take you through the five priorities of the day. First one is higher order thinking skills, which are you can say also known as HOTS as an acronym, HOTS, higher order thinking skills. And the tool that has basically been used by the different systems of education, both formal as well as informal, to develop, to inculcate these higher order thinking skills into the mindset at the young, unpolluted age is the tools of STEM education. That is, it also is an acronym that is science, technology, engineering, and mathematics, which expand for STEM. And in fact, we have gone a step ahead where we have moved into one more, that is step number two, that is STEAM, that is with an inculcation of art or arts into it. So it's STEAM. And in fact, there has been one more jump in the recent years from STEM to STEAM to STREAM, which where R involves reading and writing skills. So in fact, as it has been said, this entire field of astronomy is a blend of art, craft, and science. So today, I shall be taking you a little bit for a cursory look into this careful, or you can say very good amalgam or a blend of art, craft, and science behind astronomy in the field of the citizen science. So, my dear young friends, you know what happens is when we, how we can say, as I began, how to make you fall in love with the subject. So once we are talking of falling into love with the subject, so you know what we have to do is we have to make friends with the sky. And how to make friends with the sky? So my dear young friends, to make friends with the sky or to fall in love with the subject or to befriend the sky, what we have to do is we have to strengthen and sharpen our observational skills. Now, to sharpen our observational skills, what we need to do is, do we need to possess a telescope? Do we need to possess a smartphone? Do we need to possess a camera? I'm talking DSLR and DSLR cameras. Do we? No. We simply need to possess a set of healthy eyes and perfectly dark night skies. So night I'm talking with no, you can say, prejudice against the sun, but definitely night is, you can say, more soothing to the observational astronomers. In terms of observation I am talking. So with the set of a couple of our eyes in as our property, what we can do is we can work wonders, exploring the night sky, falling in love with the different permutations and combinations of the different stars. And to begin with, the best companion of the night sky definitely is our moon. So today, I shall be giving you a cursory look of about 5 minutes into the small project of moon over us that we are going to launch in very soon. We have almost done the background work with regards to involving all the facilities, how the project is going to proceed. And then after that, after our you can say brush up with the observational skills, we shall dive a little bit deeper into a self-explanatory project that I have been requested by the organizers to build up interest into all the young or dynamic observers, that is known as NASA's micro observatory. So this is the, you can say, the agenda of the day. And so without further ado, let me just share my screen. So there is nothing to hide. Let me share my entire screen. So I hope my screen becomes visible to you all. So this is not going to be a traditional PowerPoint presentation. So what I just am going to do is I am just going to take you into the realm of technology, as I have just told. So first of all, there is this is the world of social media. We all are active on one form or the other, another in on the different social media platform, whether it is Meta, which was previously known as Facebook, whether it's WhatsApp, whether it's Telegram, whether it's X or Twitter, or the different forms of it can be said the social media. So there is, I thought that instead of making a PowerPoint presentation, let me just bring to you for the case of self-experimentation, because today, whatever I am just going to give a demonstration or whatever I am just going to, Arti, I request you to contribute yourself. Thank you. So whatever today we are just going to brush our hands with, it will be, you can say, self-explanatory nature. So there is a platform that is known as Padlet. So today I just am going to talk to you regarding the Padlet. And as you can see, let me just post the link also so that you can just have a trial on your own at the Padlet. So this is the website of the Padlet. So this in fact is an online, you can say, a digital type of a classroom. A few of the people, you can, if they may try to make a parallelism with the Google classrooms, but definitely it is not that particular thing. So my dear friends, what happens is, see, man is a social being. So over the case of the different types of social media, if you are trying to work your way over a particular theme, say, in fact, if you are trying to observe the moon and you want to share your observations of different forms. Now, what all are those different forms? The different forms may be You could have taken a beautiful photograph of the moon. You could have taken, made a sketch of whatever you have observed about the moon. You could have written poetry about the moon. You could have written an article about the moon. You could have browsed through the internet and have found out the different links, useful information about the moon. You might be having some, say, a file or a document file that could be related to the moon, like that. So there are different forms of the media that are available in front of you. Now, how to share all these forms in it as it is, as they are. That is, if you want to share a video, let the video appear like a video. If you want to share an image, let the image appear like an image. If you want to share a document, let the document be intact in that particular form. If you want to share a link, URL, web URL, website link, let the link be like that. Or if you want to share some, say, complex scientific file, let the scientific file be there. And you simply don't want to share, but you want to discuss, you want to debate, you want to make a knowledge forum. Definitely, Padlet is one such knowledge forum. So, what happens is, over the case of Monoverse as a project, what all are the different forms of the media that I told you. We try to develop cultural astronomy, naked eye astronomy, by beginning your observations of the moon. And here, what we actually are trying to do is, we actually are trying to make the student observant about the different features of the moon, make the student observant about how the moon is behaving into the night sky, make the participant more vigilant and more observant about the patterns over which the moon is charting out into the night sky, and how the sky looks over the course of the different phases of the moon, the directions, the intensities with which the moon rises, all primarily with the help of your naked eye, followed by, if you possess a smartphone like that, and to be followed by, you can say, a little bit more blend of technology with the help of micro observatory, NASA's micro observatory, and all those things. So, see, if you can see, I have been able to post, in fact, a few of my students, they had posted their different informations over this particular Padlet format from my account. If you can see, there are documents, there are, you can say, links, there are images, and all those things are there. So you too can utilize this particular platform and create a knowledge sharing forum. So this simply was my logic of putting up this Padlet in front of you, so that today, after the session of the day, you just go and experiment. See, what happens is, there is a famous four-liner by our ex-president, Dr. APJ Abdul Kalam, the missile man of India. He had said, learning gives creativity, creativity leads to thinking, thinking provides knowledge, and knowledge makes you great. So what I propose here over the course of this workshop, because you may be joined by, you shall, and definitely you will be joined by experts from different fields. I just am a science communicator, but you will be meeting, you can say, people who have great command over theoretical as well as practical knowledge, and they will be showing you, demonstrating you their skills over serious astronomy, amateur astronomy, and citizen science over the course of next 4 or 5 days. So what I propose in front of all of you is that you just try to do experimentation. The maximum that you will do is, you may go wrong, and nobody will going to, you can say, make any charge or move any charge against you while trying, experimenting. So here also, I have just given you the link to the Padlet. Try to experience the different features of the Padlet, and if in course of, while experimenting the different features of the Padlet, if you fall into any issue, if you fall into any problem, then you really are welcome to discuss it with us. there are different ways in which you can show, in which you can share your knowledge forum over the Padlet. For instance, this was a simple Padlet that was built up by me. I can share this again to you, where over the course of moon over us, we had a serious observation session over a course of 2 months, charting out the different two lunar cycles, two lunar phases with the help of the DSLR camera. So we have mentioned plus the different, you can say, this our mobile camera also, so different exposures. We deliberately committed a few mistakes. So you can just look at the different images coming out from the different specifications that we have given, and then accordingly you can do the self experimentation, and then you can proceed further. So what now, before moving on, after this introductory talk to this moon over us, I just would like to tell that we are about to begin this entire project on the upcoming lunar cycle, and we shall be rolling out this moon over us project in the days to come. And you just keep in touch with Mr. Shovanacharya and us, and we definitely promise you that yes, we are going to take you deep into the observational field. And apart from that, what happens is, now after you have done a little bit of tryst with your destiny with regards to this moon over us with the observational skills, now there should be some food for thought for you to look into the proper scientific data. Because what happens is, as when Shourjya was talking, he was talking about two words: citizen and scientist. So yes, we all are citizens, but we definitely are moving towards the world that is known as scientist. So we need to have, you can say, a little bit of output by processing the information that is known as scientific grade of data. Not always the scientific grade of data is easily and readily available. So there are, yes, different platforms, different citizen science, you can say, forums that do provide you this particular form of data. But before, you can say, moving into those particular platforms, you need to brush up your skills as well. So today, we are going to talk about this small platform that is known as NASA's Micro Observatory. So now let me just again paste the link into the chat box for you all. So this is that particular platform where we are going to talk about this particular image processing and all those particular things. So first of all, as a citizen scientist, you need to be aware of the platforms that can provide you some serious form of information. So for that serious form of information, one of the handy tools, one of the handy platforms which are available in front of you is NASA's Micro Observatory. So I have already posted the links, and it has got a very, very, you can say, a happy-go-lucky form of a thing in which, and sometimes I do envy the young generation that at our times we did not have the access to such handy form of information. So you are those chosen ones, you are those lucky generations who can work over these platforms. And there is very important feature of this NASA's Micro Observatory. The important feature is that it is platform independent. Now let me explain to you what this platform independent is. What does it stands for? So majority of our young friends who are joining today and who will be joining us for the course of next 5 or 6 days, you are young generations. You may not be having the access to those, you can say, subtle machinery in the form of laptop, in the form of, you can say, computer systems, or very subtle instrumentation. So here, NASA's Micro Observatory provides you a very good opportunity of self-experimentation, where you need not own even a computer system or a laptop. You may be just having a simple smartphone, that's enough. For instance, if you talk to some serious astronomer, They may be talking about the different operating systems like Windows, Linux, Ubuntu, like that. So platform independent here indicates that you need not be bounded by the ownership of any particular operating system. You may be having Windows, you may not be having Windows, you may be having Ubuntu, you may not be having Ubuntu, you may be operating on Android, you may be operating on Apple iPhone, well and good. Whatever platform you may be operating, this NASA's micro observatory is handy and it works well. So if you have a laptop, you can work with it. If you have a smartphone, you can work with it. If you have a MacBook, you can work with it. If you are operating on Linux, Ubuntu, you can work with it. If you are operating on Windows system, you can work with it. So Android phone, you can work on it. So it is very, you can say, lucky and very important platform specifically for the young students. So what you really can do is you just can go to this particular link, and then there is towards the this menu there is an option that is known as control telescope. So I just would request you all that whenever you are going to this particular platform, try to feel the ownership that you own something. So you just go to this control telescope form, and once you are going to this control telescope thing, what really happens is you almost get a chance to control something that is known as robotic telescope. There is an array of telescope that is being deployed by NASA under micro observatory project, and those robotic telescope you really can control from here. Control from here sitting at your homes does not mean that you are operating it mechanically. It means that you can feed your command over here directly, and after feeding your command, you can get as good picture as somebody may be getting from his or her own telescope. So now as I was talking, there is something known as self-exploration. So now let us self-explore this particular control telescope feature or facility of NASA's micro observatory. So now what happens is when we talk about sky as a novice, as a new entry to the field of citizen science, when we talk about sky, what do we feel? We feel it is just but stars, just but moon, or you can say some planets are there, then sun is there in the day. But when you come to this, select your target, that what you want to photograph. You see, there are different classifications, different categories of the objects that are there. So in the world of 21st century, or you can say in this era of computer science and technology, Professor Google is the best professor, that I always say jokingly. So what happens is, if you see as a young exponent of astronomy, it gives you, even this particular page also gives you a lot of chance to explore. What is there to explore? You might be thinking. You see, where there is a will, there is a way. So let us make a will to explore the cosmos scientifically. There are three major divisions that are given. First one is the solar system. You see, then second is a variety that is known as stars and nebulae, and third is galaxy and beyond. So you see, the entire night sky that we see as a very dark plate of objects shining, twinkling, it is divided up into these all different varieties. So you can just browse into it, you can just have a self exploration why these solar system objects are kept different from stars and nebula. Why, what the meaning, what the word this nebula means, why this stars and nebula is different from a galaxy. Is there any relation between stars and galaxy, and what does that and beyond means? So all these explorations, they really can be done by you. You really can look over it, self explore it. So build up the curiosity in yourself, and that could be the first step towards the greatness, as I had mentioned in the first four lines given by Dr. APJ Abdul Kalam. So nebula, let me just explain to you. Nebula is that is a region of dust and clouds, which is the nursery, so of stars, where stars are born basically. So that portion in the cosmos where the stars are born is known as nebula. So isn't it, you can say, very interesting if you are able to photograph the place where stars born, where stars are given birth, where they are born. Isn't it something you can say great if you are able to take a photograph of the galaxy? Is it worth doing if we are to explore the different planets of the solar system? Isn't it? So just have a look into it. So now what you have to do is, let us clearly march into it. I'm just taking one, you can say, photograph. Let me just take Rosette Nebula. So here, what happens is, first of all, what you have to do is, when we are up into the sky, that is where I told you, begin with the observational astronomy. And in that observational astronomy, with the naked eyes, with the pair of eyes, both the pair of eyes, you tend to gain a little bit of insight into those jargons of astronomy. And then you can take a photograph of the galaxy. available for this astronomy also. So what happens is filter. Filter means to filter out. But what are we filtering? We actually are filtering light is a combination of the different wavelengths of the light. So what happens is I'm talking about, say example, if there is something known as a red filter. So what happens is, as it says, it will allow only the red wavelength of the light to pass through it, and it will reflect off the other portions of the light from the spectrum of the light. So if it is a green filter, it will allow only the green light to pass through it. If it's a blue filter, it will allow only the blue light to pass through it. And no filter means all the light, all the entire electromagnetic spectrum will fall onto the detector and or your CCD or CMOS of your CMOS or CCD detector of your camera, and you will be able to take a photograph. So if you want to see that is 3-color image, so you can take the multiple picture. So here I am just taking the 3-color image. So I have chosen my field of view. I have chosen the time for which I want to expose the telescope for the image, and I have chosen my filter, and let me just continue. So what happens is, here I am just putting my email address to it. Let me just put my age. Let me just put my gender. And here you have to put the state. So here, if you are from India, don't make IN, okay? IN stands for Indiana, that is a state in America. So if you are outside US, you have to just put outside US. So I am outside US. So how often you have used these telescopes? You just put it how many times you have used. I have used definitely more than 10. Then you try to rate your knowledge of astronomy. I am just a beginner, so I'm just putting it 4. And do you want the micro observatory to contact you? Yes, definitely. Why not? Who would like to miss the important piece of information or the knowledge that is being provided by macro observatory? So I just submit it. So what happens is, so this Rosette Nebula, which is 5,200 light years away from us, it means if you travel with the speed of light for 5,200 years, then you reach Rosette Nebula. It is a star-forming region. It's in the constellation Monoceros with a normal 1-degree field of view with an exposure of 60 seconds and filter are red, blue, and green. Yeah, I have just ordered micro observatories, NASA's micro observatory to take the photograph and just inform me on the email. So what is the beauty of this? It will take the photograph within say a day or two, and you will get the photograph, scientific grade data on your email. Okay, so simply by taking this, the data is on your fingertips. So that Karlo Dunya Muthi mein, yes, the world is definitely in your fist. It is at your fingertips with the help of this micro observatory. So let me just take you back a little bit more. There is something known as NASA's Astrophotography Challenge of summer 2024. So my dear young friends, what you really can do is, you can just go into this special target of this micro observatory, and then what happens is, you can go into this particular thing, and if you see this here, this Cassiopeia A, this is that NASA's this particular astrophotography challenge. You go into it, you try to take the photograph, you try to process the image, and who knows, you may win this particular challenge. Now, simply taking the photograph and simply garnering the information will not work wonders, because what happens is, NASA provides you, or say in fact this micro observatory provides you the data in a particular format that is known as flexible image transport system. Now what is this flexible image transport system? This flexible image transport system, or the FITS files, these are the different scientific grade data. As we take the image, you might be knowing about the JPG images, PNG images, TIFF images, like that. Similarly, we have got FITS images for astronomical utilization. They have got tremendous amount of information that are stored in them. So what you really need to do is, if you are going to participate in this NASA's astrophotography challenge, you can just come to this project and activities. You see NASA's astrophoto challenges, and this season of NASA astrophoto challenge, you can go there, and here this is this particular Cassiopeia A, and all those things are there. So all these particular things are given, and for the sake of your information, because yes, There are too many links that you may have to browse through. So what I just am going to do is, I'm just going to paste the link directly into this particular chat box, so that you can, whenever you feel free, you really can go to it. When you are confident, you try your hands over it. And yes, there are different sources of information. You just, you can say, submit your astrophotographical entry, and my best wishes are with you. So now, simply as I was saying, simply garnering the data will not work. To go into this astrophoto challenge, or to, you can say, raise your bar, you need to have a little bit of proficiency into this particular image processing. There is something that is known as image processing, and we all are aware of this image processing. I am pretty much sure that majority of us, or in fact all of us, they may have tried image processing, even though we may not know the word that is known as image processing. How? See, we all attend different functions, marriage, then in our college there are different functions are going on, all the day in India specifically, or entire world, there is one festival or another each passing day. So we do take the photograph, and once we take the photograph, we all might have tried applying different filters on the photograph, increasing the contrast and all those different colors, adding special, you can say, features onto the photograph. That is known as image processing. So we have done up till now in a layman format. But when we are doing for something scientific, we need to lay our hands over it properly. So I'm just giving you a cursory look into the image processing. So let us suppose that we have gotten an image from NASA's micro observatory over our email, and we have downloaded that image, and that image in the FITS format, it will not open on any, you can say, regular software. It opens on specific software. So for that sake of yours, there is online, again, platform independent. Okay, you can try it from your mobile also, from your system also, and whatever form of your mobile is, whatever operating system your laptop or your desktop is, you can try your hands over it. Okay, so that is known as JS94L. Now what this 4L stands for? It stands for learners. So let me again put this particular processing link into the chat box for the sake of your ease and convenience. So what really happens is, I am supposing I have given my image from NASA's micro observatory for observation, and I have received it on my email. I have downloaded it. Now what I need to do is, I need to go to this image, and from this image I need to click on open. And once I am clicking it on open, what I am just going to do is, I will be redirected to that particular place, and etc, etc. And even if you might not have received any image as of now from micro observatory, what you really can do is, you can just go to the archived image. NASA's micro observatory is very much generous in allowing you to do the processing of the different images. Okay, so by default also this particular image is open. So let me just try my hands over it. If you see, each image has got a specific information, and right now if you look at the image that is in front of my screen, you might be saying, what the hell is this? Because when we are talking about NASA's micro observatory or scientific image, let me just take it to this Wikipedia page of this Cassiopeia A, which is a part of NASA's astrophotography challenge. This is, you can say, a popular imagination in our eyes. When we think of image of from this astrophotography, or image from cosmos, these sort of images, they do strike our imagination. So, but on one case is this, and on the other side is this. Definitely, my dear friends, this is a raw format of the image that we do receive, and from here we have to do the processing to reach up to this particular stage. So the journey from this particular to this particular stage is that journey of image processing. So what you need to understand. I just would conclude by, I am just not would not go into so many details into so much image processing. But I am leaving it for you to understand self-experiment, because there are guided, you can say, tours also available. And if you want a little bit of more piece of information, we are there to help you out. There is no issue. But because of the time foundation, I will be talking only about a few core issues which you need to understand while doing the image processing. So, what happens is, this particular dark patch of the sky with a few streaks looking here, a few streaks looking there. And mind you, I have not done the processing of this image before. It just appeared in front of my screen courtesy to NASA's micro observatory, and I am talking about it to you. So this image has got a specific information, this being the scientific grade data. If you look at this particular region, there is something known as, in the green color, there is something that is changing. So this information basically is with regards to the brightness of that each point in the sky. While I am hovering, you can say, my particular screen, you see, towards this. Now let me just highlight this information. So there is something known as pixel value, there is something known as physical location. So this particular pixel value, it actually is talking about the level of the brightness of that particular point where my cursor is hovering over it. So as you can see, this particular pixel value is changing. And mind you, what is this pixel? Pixel is an acronym, or you can say short form, for picture element. So it is the most basic unit from which each picture is contained of. So if you try to divide each picture into grid of data, the smallest element that you get, if you try to draw an analogy from the body, we have got a body. Body is composed of organs. Organs are composed of tissues, or in fact an organism. Organism is composed of organ. Organ is composed of tissues. Tissues are composed of cell, and cell is the basic building block. Similarly, each picture, whatever we are going to see, is composed of the basic building block that is known as a pixel. So pixel, the analogy can be drawn to a cell. Okay, in our body I am talking about. So this particular picture element or pixel, it gives this specific intensity of the brightness. And the moment you try, how to control the extent of the brightness. Okay, you are the winner. You know how to do the image processing. So the entire game, okay, it is easy to be said than to be done. That I am telling you. But the moment you champion this entire thing of controlling the brightness, you have you can say started your first step into the image processing. So first of all, what we need to do is, we need to enhance the images. Okay, so as far as this particular thing of this particular image is concerned, that is in front of you, because now only 5 to 7 minutes of my talk is remaining. So just stay with me for 5 to 6 minutes, and then we can have an open session for discussion. So in this particular picture, in this particular scientific grade of data, what has happened is, computer has assigned a shade of color to each of the particular pixel or the picture element that is within this scientific picture. If you see towards the bottom, there is a scale. This I am talking about this scale where my cursor is hovering over. From black to white, they are different, and if you can see, there are different shades. That is, as we proceed from left to right, the contour or the texture is moving away from black to particular proper white. So what happens is, very low pixel values, they are assigned the shades of black, and very high pixel values, they are assigned the bright shades of white. So if you see the high brightness limit, if you see, it has given 4095. So any picture element that is 4095, that is the brightest portion. If you see here, my cursor is hovering over, so it is 4095. I am just put it here. If you see at the pixel value in the green color, that is 4095. When I am moving over the black color, if you see, the pixel values are very less. So as per the different portions of the sky, each picture element has been assigned a value by the computer. So now what we need to do is, we need to understand, we need to enhance this particular image. So we need to bring the details into this particular image. So first of all, what we need to do is, we need to use a proper scale. So first of all, if we are measuring the brightness now, as I am talking now, we are going to champion the brightness. How to champion the brightness? We need to measure the brightness. Now to measure the brightness, we need to set something known as a scale. So here, when we are talking about the scale, there is an option known as a scale. And mind you, if you remember, when I was talking about the NASA's macro observatory, giving you a little bit of detailed information into taking the different types of images, I told it was solar system, then nebula was there, then beyond that nebula was there. So you just need to understand at the moment that when we are moving within the solar system, the scale that has to be chosen has to be linear. When we have gone beyond the solar system, because this is Lagoon Nebula. So as you can see the name Lagoon Nebula, this is the Lagoon Nebula. Okay, so the scale has to be logarithmic in nature. Log scale has to be chosen. So I am putting it log scale. Now you see something more prominent has happened. Now there is a signage scale is also there, signage scale is also there. The different types of scales are there. But if you see, this was the default linear scale. If you are working within the solar system, this linear scale will do good, well wonders. For example, moon, planets, etc. But once you move out of the solar system, you have to choose an alternative scale. So for micro observatory, try using log scale. Now you may be thinking, previously it was saying, you can say the different pixel idea, you can say intensities were defined. Now even though the stars have become visible, a little bit of, you can say, dusty area has also become visible, but there is nothing, you can say, prominent black or prominent white that is visible in front of all of us. So now what we need to do is, we need to adjust this brightness limit. I hope that I am audible to you, because kindly stay with me for only for 5 minutes, and then we can open the session. Okay, because I am just talking about how to, you can say, start playing with the brightness scale, and in the course of the play itself you will learn how to do it. So you know what happens is, if you see at the bottom, okay, now I am just putting it the scale to linear again. You see this black portion and the white portion, the blending. Now I am changing the scale to log, and if you see how this black and white is changed at the bottom scale. Okay, so now each pixel intensity has been defined differently. So now since we are outside the solar system, we have changed the scale to logarithmic in nature. But you know, the sky has become gray in nature. As we move around now, the low pixel identities, they do change. So now what we have to do is, the values around, say, if you say 280 or 300, they are assigned, you can say, medium gray color. You see, this is a medium gray color. So we need to shift a little bit of the pixel values to the bottom of the color bar. So now what we need to do is, if you see towards the left, in the by default the low brightness color is there. So now first of all we need to bring out something known as pixel table. Okay, now I am putting this pixel table at a place of my convenience where I can see it. And now what I am going to do is, I am hovering my pixel over it. So here we have to choose something that is known as midtone, or the, you can say, the lower intensity values. So the lower intensity values, this grayish in nature, where there is star or where there is some body that is appearing that is white, where there is a sky or deep sky, it is appearing as grayish in nature. So you know what we have to do is, we have to find out by hovering the pixel here and there, which could be the probable lowest value. So if you can see, I am just able to see at 280, 290 are these values. So what I am just going to do is, I am going to change the lowest bright limit to 350. Okay, so now you see, just by simply changing it to 350, the lowest bright limit, it has gone like this. Okay, now you see, just when we have started to play with this particular scale intensity, it has slowly changed, and this particular nebula, it has now appeared in front of us clearly. You can zoom also, you can flip the particular object also, like that. You can do the flipping around x and y axis, whatever you want. We can zoom in, we can zoom out, whatever way in which you want to see this particular nebula. So you know what now we are just going to do is, here if you see the intensity is 339, so the lowest brightness limit is still not reached, it has 339. So let us make a little bit of more correction. Now I have done the more correction, you see it has appeared more prominent. So now the lowest brightness limit we have corrected. Now, how to do the lowest brightness limit? Let me just recap. Open the pixel table. Try hovering your this particular mouse pointer over this pixel, or if you are doing it with the help of your this particular mobile, you just zoom it in properly. Try moving your tapping area over this particular different images, and you just find out where could be the lowest intensity that's available. So if you can see 339 I have put, but at a few places it's 337 also. So it is just a hit and trial by seeing it over it. So I am putting a 337, doing it, you can see now more prominence is available. We are now able to see this particular lagoon nebula in the preliminary stage. Okay, still a lot needs to be done. Okay, so now what we need to do is, now we again need to hover our pixel over it by using the pixel table and see the highest brightness intensity. Okay, now where is the highest brightness intensity? You see 4095, where the crossbar is 4095, 4095. If we are able to find out the brightness limit lesser than 4095, we have to choose the brightness limit here also accordingly. Okay, so now what we have done is, here the lowest and the highest brightness limit, they have been adjusted. We have played with the scale. Now what we need to do is, we need to do a little bit of tinkering, that is stretching, contrasting and squeezing. If you see at the moment, if you see the stretch oblique, the contrast is defined as 1. So I am just holding my mouse and I am just trying to do the stretch and contrast. So with regards to, I am just playing with the stretch and contrast, and because here it was, you can say too much, you can say grayish in nature, the sky, I just want to see the perfect, you can say blackness also, as well as I don't want to destroy the intensity. So I'm just putting this particular contrast value, the white shift. Now if you see, the moment we try to change the stretch and contrast, you see towards the bottom, the scale also is changing. You see here also, now the brightness, this black limit and the yellow limit, this is changing. So by default, this stretch is 1. Now I think the central mid portion is more prominently visible. The sky also is prominently visible. So we have done a little bit of stretching and contrasting. If you think that I have done way too more, let me just do it little less. I have done it 1.2. So anything you can say, we are just trying to move this particular blending into it. Then there is one more option that is known as shifting or biasing. So you know what happens is, it actually changes the cutoff points which are stretched within the you can say stretch or contrast. So you know what we do is, this particular stretch and contrast, it squeezes the area of the black and white. Okay, so if you, this is the squeezing the white, squeezing the black, like that we have done the squeezing. We are choosing the particular blending of this black and the white portion. Now here, you know, by using the shift and the bias, we are changing the cutoff points which are being set up with the stretch and that is this particular thing. If you see, when we were doing the stretch and contrast, this black and gray portion, it was, you can say, squeezed up into a little bit, that is proper black to proper white. This gray portion or the blended portion became less or more. But you know, when we are trying to do this shift and bias, what really is happening is, we are just putting up the beginning of the cutoff points, that is from which portion is the particular black, which portion is the particular white, like that. So that is the width of the squeeze. It actually does not change what we did on the contrast slider, but it will change where the change in the color scale will occur. So all these things, they really are necessary. You know what happens is, sometimes when we are doing the scientific study and we are more interested in the sky portion, then we need to know that in the central bulge of that particular nebula, we are not interested in the sky. So we can do a little bit of change like this as per our requirements. Okay, and if we are more interested in this particular nebula central disk, we can do it like this. Whatever, if you want to study the intensity and all those things, so all these things, they really depend upon what portion of the sky we really intend to study. So at the moment, I have done this. So we have done this particular thing, and what we really can do is, we can in fact go to the image and we can choose the display fits header. And once we choose the fits header, now we can see, read a lot of information, background information with regards to this particular file. And that when this image was taken, at what place this image was taken, under what filter it was there. So you can see where it is, the filter is red in color. This telescope is Donald. This is the filter. And so how much was the focus? How many pixels are there? Which type of image is there? What was the local latitude and longitude? So who was the observer? And all these things are there. Which country, which place, and all these things they really are mentioned. So it is red filtered image. So it is red image. So what we need to do next is we need to put that red color into it. So what we are going to do, we are going to go for color, and here what we are going to do is red image. So now we can do a little bit of more tinkering as per our requirements, whatever we want to put it there. So whatever our scope of interest is, whatever we are trying to do. So this is a true color image because it was a red image. We can generate false colors also. For example, if we are interested in different forms of study, we can do the different formats. We can do, you can say, apply the different filters over it. Then we can do one more important thing. We can create an RGB image by opening multiple images over it, aligning them properly, and analyzing them. So this, in fact, and not only this, we can do a little bit of analysis also. We can, for example, I am just taking the case of, say, gray image. I am doing it, and let me just show you this final thing. So these are a lot of tools. We can do blinking and blending and all these things. Nice. So I'm leaving it for you for the self experimentation. And apart from that, there is in the training and resource section, there is a very good deal of information that is being provided, in which you can choose the true color image. You can use an advanced RGB image. If you are participating in the NASA's astrophotography challenge, you need to know how to create advanced RGB image, and all those things, they really are there. And then if you are studying it also, even though this is a very preliminary tool, what you can do is, for example, I am just choosing it, say, box. I want to study this much portion of this particular image, and I'm just taking it. Say I want to study this histogram of this particular image, and I want to understand this. So this is this particular information that I want to study. So this very good piece of information really can be brought out, and we can do you can say, statistics also with regards to the region. If you are interested in some scientific studies, say the noise is there, full width at half maximum, all those piece of information also is there. And then, of course, we really can do a little bit of 3D plot also. If, for example, if you are studying a binary star system, then if you see these many stars are there, and intensities and all those things, they really are related. If you want to study, you really can do a 3D plot, and all those things, they really can be studied. And if you want, you can really plot a profile. So I am just creating a line region. So here it is. So I am really plotting profile, that which particular portion of this particular image is there. So all these things we had to discuss today, and this is what that I had. The only thing that I just would like to say to you is that imagination, imagination, and imagination. And you try to blend your imagination with art, craft, and science. We don't finish simply here. We do promote students, because when I am talking about, say, we do have got these different publications also. For instance, when I am talking about this moon over us, there was a publication that recently came out in the Regional Institute of Education, RI NCRT Bhopal's Journal of Education. Then if you see, a few of the students, they had done their work over this NGC Reflection Nebula 2068, and using the image GS9 and GS9-4L. And so, what happens is, they really have come out into they have done their project, and so you see the different imaging and all those studies they have done, and they have come out with different conclusions with regard to their study, and they have come out, you can say, wonderfully well. So if these students, they can go for the publications, why not you? And as a concluding factor, we have got a particular very serious, for the serious people who are really interested in the field of astronomy. We are Global Sky partners with Las Cumbres Observatory LCOGT as part of the 100 Global High School teams. And even the moon over us also is one of those platforms where we really go deep into the sky using the 0.4-meter robotic telescope. Here we target galaxy, nebula, globular, and open star clusters. And we also publish, where our students who have done some serious work over this particular thing. See, we have done Kshitij Srivastav, he had done his master's thesis by using this LCOGT, and we had worked over the exoplanets. So all these observations, the photometry work that we had done together, so these are being taken by a few of our students. We had done the photography of the moon. We had done the photography of the different, you can say, comets. And this is an exoplanet, a part of the master's project that was done by Kshitij. So you really are welcome to join us. And we shall be resuming this particular project again from the month of August. You really are welcome to join us from the month of August with regards to Last Cumulus Observatory. And I really thank the organizers for providing me this opportunity to speak on the inaugural session of your astronomy bonanza. I hope that I have not overshot the time, because I have got a very bad reputation of overshooting the time, but I was given about 95 minutes to speak. So now I open the session for all. And if anybody has got any doubt, I really welcome you all. Let's have an open forum for discussion. Over to the hosts and the organizers. Yes, Mananji. Mananji, you have raised your hand.
Yes, sir. Hello.
Yes, please.
Sir, that whatever you showed till the last 30 minutes, I still think that, understanding and comprehending it, it's like it was a big dump of information for, I
Yeah.
think, all of us here. So, how do you think we can, understand that more and more? Or
Yes.
how time it is going to take to me?
Yeah.
Like,
So thank you, Mananji, for this particular question. And actually, what happened was, the idea of the talk of the day only was to bring up interest in you and bring out such questions as you have asked. So now coming back to your question, yes, definitely, it was quite a, you can say, sizable in form of information. So what you really can do is, micro observatory, the links that I have shared, what you all can do is like this. First of all, you can give a request on the micro observatory, NASA micro observatory, and try your giving your request on different, you can say, sources of the objects. Try your hands of for the objects within the solar system. It may be even sun also, it may be moon also. Try your hands at different nebula. Try your hands at different galaxies. Okay. And then what you do is, you make a library of the request that you have received into your system or onto your device, whatever you are operating from. And then what you do is, today the demonstration that I gave particularly is with regards to a single image. So what you really can do is, if you can just recount whatever I have told, well and good. If you are not able to do, no need to worry. Within this NASA's micro observatory itself, there is a resource section where they have got very beautiful videos of how to, when to, and what to. That is, how to do the things, when and at what stage you have to do whatever things, and whenever you are in case of any particular doubt, there they have got their helpline as well. The frequently asked questions are also there, and we also are there to guide you out in case of any issues. So what can be done by you and by our honorable other viewers is, they to take it phase by phase. Begin it with the solar system, because there you don't have to do a lot of tinkering with the data, because the backdrop also is, you can say, not so complex. The objects within the solar system, they are also not so complex. Don't take it not so complex mean that you don't have to do anything, because if you are doing over the moon now, you will understand to bring out the features. So there, when you are doing with the moon or with some sunspots, you will love playing with the you can say brightness that I really told. And once you are playing with the brightness and then applying the different filters, different false color filters, so you will get to understand how to do the preliminary image processing simply by adjusting the brightness and the pixel value. The length of the videos that are being given by NASA Macro Observatory, they are not very long, 4-minute videos, 5-minute videos like that. So you really can rely over them. We also have got our different, you can say, platforms over which you really can contact us, and we can have, you can say, one-to-one discussion sessions also if you are in case of any doubt. Now, once you are proficient with regards to that particular image processing in that particular solar system, then you move to galaxy, not to nebula, galaxy. Because galaxy, it has got a little bit of limitations into it with regards to brightness and everything, and it has got different features. It has got complex features also, but not so complex as compared to nebula. Then the backdrop also, because galaxy is highly prominent, it has got very bright disk and everything is there. The backdrop becomes, you can say little less you can say prominent in comparison to galaxy. So your prima focus can be on the galaxy, and then once you are into the galaxy, then you can move to the second stage, that is mixing the different colors, then playing with the blinking portion and all those features. The image mathematics is there. Then the different features, that is calibrating of the image, can come at this stage. Calibrating the image means that is dark, the art of doing dark subtraction and all those things that can come at this stage. Micro observatories video again are available for this particular stage. And then once you are done with this galaxy, then you proceed to nebula. Because when you are doing nebula, you have to take care of the foreground also and background also. Because the background also is properly visible and the foreground is the nebula, that is the big bright object, big object. So then after that you have done the nebula in addition, then you can go to long exposure, higher order of RGB images, and even you can change the software also. Because micro observatory is the beginners software preliminary level. Then there is an advanced level of GS9 also. That is also again online only. You did not download it. Then you can use Chandra X-ray images over it, and you can do a lot of serious study also. Study also can be done with this micro observatory as well. So this is the pathway that I prescribe to all the people. Begin with the solar system and with the moon and sun, then go to planets, then go to galaxy, then go to other complex features like nebula, and keep a track of your observational skills with regards to the tutorial videos that are being provided by the resource creators. Okay, Mananji? Sure. Anybody else? And yes, of course, I just would like to inform you that if you want to hone your skills over the smartphone astrophotography, because you just try today, or even because when this full moon is approaching or any half moon is there, you just try to take your smartphone out and you just put your mobile camera or smartphone camera in front of the moon, whatever the phase of the moon, crescent moon, half moon, quarter moon, gibbous moon, what happens is, really you will be observing only the full moon. It will only the form of a full moon be captured in your particular mobile, because we have a habit of taking it on an autofocus mode. So there are, you can say, expert astrophotographers who really have championed the art of smartphone astrophotography. And today we are blessed to have one astrophotographer, smartphone astrophotographer, who is co-collaborator of mine also, and Shobhan Acharya sir also, Mrs. Chitra Singh from Hexstar, Haryana. She is an ex-teacher and astrophotographer of smartphone astrophotographer and naked eye visual astronomer of observational astronomer of national and international repute, who has done extensive work. And if you remember the paper that I showed you with regards to moon over us, Chitra ma'am was one of the co-authors. So you can go into the guidance of those ace smartphone astrophotographers like Chitra ma'am also, who utilize the limited resources to the maximum extent by using the prowess and the skill of bending the way in which the mobile can be operated. And people like Chitra ma'am, they have taken excellent photography of Milky Way, of planets, of constellations, of different features. Right now there are summer triangle is visible. There are different asterisms, the different constellations are visible. Try your luck, try your hands by using the astrophotography, by using the smartphone also. So it will make you, again, as I said at the very beginning of my talk, fall in love with the subject. And if you are at Moon Over Us, if you are with us LCO, then people like myself, Sovan Acharya sir, Chitra Singh ma'am, Mr. Suresh Meduru, SN Sukumar Ayerji, we are there to guide you all. And yes, of course, the mentors of ours like Ms. Bonnie B. Truber, they are also there to guide you at every stage and every step. Thank you.
Thank you, sir. First of all, your time was worth it, and your words always inspire us. And thank you to the organizers again, and thank you to you guys also that you have joined. And one thing that it is just the beginning, and we have 5 more sessions. One is tomorrow, so join on time. And thank you again to everyone for joining.